Hello everyone, let's talk about Leetcode question 143, reorder list. Now this problem is very popular and for good reason, as it covers some of the main concepts found in linked lists. This question asks to rearrange nodes in a linked list in a way that satisfies the conditions met here, which are that you may not modify the values of the linked list nodes, only the nodes themselves can be changed, and reorder them basically in a way where the first two nodes are the first node and the last node, and the second next two nodes are the second to first node and the second to last node, and so on, if that makes sense. Let me illustrate more clearly what this question asks and what the reordering looks like. So here's the first example illustrated, and these arrows show the modification of the nodes in the new order. So you have 1 to 4, 2, 3. The same applies for the second example. You have 1, 6, 2, 5, 3, 4. You're jumping between the first and last over and over until there's no more nodes left. So how exactly can we solve this problem? To solve this problem, we can split it up in 3 steps. The first step would be to split up the linked list in half. Why would we do this? We need to split up the linked list in half so that we can manipulate the second half of the linked list. With the second half of the linked list separated, we can now reverse that list in its entirety and then merge it together to satisfy the condition of the newly formed linked list. Let me show you what the code looks like. Okay, so now we want to, like we said, find the middle point. The first and second half of the linked list is what we want. So let's use the common code that is used all over for finding the middle, and that's okay, and now we just have the middle point, which is slow. And now that we have that, we can define the first and second half. So the second half is slow.next. The next allows us to go to the first node of the second half of the linked list. And then previous is defined as slow.next equals none, which will point to the nothing, which is what we want for the last node of the first linked list. And this also conveniently allows us to define what the reversal will look like. And this problem is similar to the reversal of a linked list, which is an easy problem on Leetcode, and it's the exact same concept. So what we're going to do is loop through the second half of the linked list. Then let me real quick explain what's going on here. So you have your second and previous. Now we want to loop through it, and the temporary variable will be second.next. Let's say if the first node is 4 and the next is 5, second.next, so 4 pointing to previous is none. And then previous is now defined as second, which is 4. What's happening here is basically you're growing a linked list starting at none and defining the first node to point to previous, and then defining previous as that first node. So what's basically happening is that you're growing a reversal of a linked list. So it would be 4, none. The next loop would be 5, 4, none. The next loop would be 6, 5, 4, none, and so on. Okay, so for the final step now, we just need to merge the two halves. So we can define the first and the second half. We define the first to be the head because that's where we start, and previous to be the start of the reversed linked list. So we can now combine them appropriately by looping through the second half. Okay, now let me explain what's happening. Basically, we loop through the second iteration, second half, sorry, and then we are defining the temporary values of the next nodes, first on next and second on next, so the next value of head and the next value of previous. We then define correctly what the node should be, so first on next should be second, head previous, so in this example it would look like 1, 4. And then, now that we have those defined, we want to redefine what first and second are. So first is now temp1 and second is temp2. And the next loop, you could see that the sequence repeats, and the first node of the first half and the first node of the second half are combined, and so on. And finally, the time complexity is O(n), and the space complexity is O of 1. Since there's 3 passes, we go through once looking through the midpoint, another time reversing the second half of the linked list, and a third time to combine the 2 linked lists into one. Makes it a time complexity of O(n) and a space complexity of O(1). And that would be it for this problem. Hope you learned something, and I'll try to see you next time later. Thank you so much.